I wanted to show you one of the calculator active delta math questions. Here is the function, and we are given this f of x, that x cubed plus 5 sine 2x. And one, we know that's continuous and it's differentiable, right? They don't have any breaks or interruptions in my sine graph or my cubic. So now we are looking for the values that would satisfy our MVT over that interval. So now we're going to use our calculators. In our y equals, we're going to type in our function, x cubed plus 5 sine 2x. We're also going to go to mode and make sure that we are in radians. Keep it there, unless you do physics and you need it in degrees. Anyway, so that's now in my y equals. So now I'm going to plug in my f of b minus f of a over b minus a. My a and b here are 0 and 2.5. I like to start by going to alpha, that's green, y equals, just to pull up that nice little fraction. Otherwise, just make sure you're using the right parentheses. And then we go to alpha trace for all of the y's. And that looks like so. And we get 4.3, we get that business, right? We're going to need that. And we are not rounding until the very end. So we're going to take that value, and I think you all said that you were comfortable using that. We're going to stow that value into, I'm going to pick A, alpha A. Okay. Next, remember, we want to figure out where is that derivative? Where's that instantaneous rate of change also equal to 4.33? So we first start by deriving. Don't forget about that chain rule for the second problem, or the second term. And remember, we want to figure out for what x value is that derivative equal to our 4.332? And you might remember we stored that value into A. So in my y equals, I'm now going to put that in to my y1, so I can figure out where does that cross the x-axis. Where is that statement equal to 0? So I have that statement in my y equals, and now I'm going to go to my window, and I'm going to change the x min and max to my interval so that I don't mistakenly include some x value that isn't in that interval. All right, so now, and then my y min and max, those are good just because I just want to see where this crosses the x-axis. So I'm going to graph it, and I can see that I've got zeros in 2 different places. So I'm going to have to do some calculations twice, or my calculator's going to have to. So we're going to go to second trace, that's calculate, and we're going to calculate the zeros. So I'm selecting 2. And you'll notice that left bound is a little close to 1, so I'm going to say left bound is like 0.2. And that way I just don't have to have my cursor moving all around. And then my right bound, I'm going to move it to the right of that 0, enter my guess, enter. Oh, and I don't know if that's clear. This is a little out of focus. That 0 says 0.6245. There it is. So 0.625 is going to be the first. Now I need to repeat this process for the second 0. And that looks like 1. That's a little less than 2. So I'm going to start with my left bound being, how about 1.5? That's safe. And then we're going to move that cursor so that it's to the right of that 0. That's good. Guess, enter. My second 0 is going to be 1.957. Whoa. So next we type in those 2 zeros. One was 0.625, and then we tack on the second. Cross our fingers, and we're good to go.